Question 7, they've given us some graphs. They haven't clearly identified the x and y axis, so go over it here. X axis and the y axis might make things a little bit clearer. So there's two graphs given to us. A positive quadratic. It looks like it can only be one positive quadratic in this one. This one here. Coming down and around. So that has to be x squared minus 3x minus 4. That factorizes to be x times x. 4 times 1. And it will be plus 4 minus 1. So the roots are 1 and minus 4. So it's halfway across a box. So that must be the number 2. And this one will be minus 4. That does match off then for the blue. And then the exponential 2 to the power of x will go through the point 0, 1. 2 to the power of 0 when x is 0. Anything to the power of 0 is 1. We know these exponentials go through here. So the red one, it's actually labeled 2 to the power of x. So that's 2 to the power of x, the red one, and it asks us to identify the correct graph for each function, and there's only 2 of them. So we also have a pink one. It's an inverted quadratic, or minus x squared. And we have the green line, which is a linear, kind of tricky enough to see. As to graph the following functions in the domain 0 to 6. So let's see what answers we get. Set up your table. So we want to find values for x squared, minus 7x plus 10. So we're going to get 0, 1, 4, 9, 16, 25, 36. And minus 7, we're going to get 0. We'll put our 10s in as well while we're here. So minus 7 times 1, minus 7, minus 14, minus 21. You should be able to see the pattern with these quite quickly. Minus 35 and minus 42. So 0, 10 is the first point. Then we have 1 and 10 is 11, minus 7 will be 4, 1, 4. Then we have 4 and 10 is 14, minus 14, that will give 0, 2, 0. And we can see if we factorized it, we would get x minus 2 by x minus 5. So the roots are 2 and 5. So 5 should give 0, 2. So we have 9 and 10 is 19, minus 21 is minus 2. So 3 minus 2. And when we put 4 in, we get 16 and 10, 26 minus 28 minus 2 again. 4 minus 2. Then we should get 0. 25 and 10 is 35. Minus 35 is 0. And then 36 and 10, 46 minus 42 is 4. And you can see the symmetry here with this graph. So I'll just change the scale on the y-axis and we'll fit all these in. So 0, 10 and 1, 4, 0, 10, 1, 4, 2, 0, and then 3 minus 2 and 4 minus 2, 2, 0. We know 5, 0 is a point. And then we have 3 and 4, both at minus 2. Minus 2, minus 4. So here and here. And then 6 was up to 4, matching off with the other point to here. So if we sketch it, maybe come down and do the bottom bit first. Now, let's look at the other equation now, g of x plus 3. So we just need to get the points at the end of the range. So 0 when x is 0. We're going to get y equals 0 plus 3. So y is equal to 3. And when x is 6, we're going to get 6 plus 3. Y will be 9. So the points 6, 9 and 0, 3. So 0, 3 will be here, and 6, 9 approximately here. It looks like they do cross over at one of the points. Looks like this could be a point of intersection, so let's check what 1 is equal to. We know what it's equal to on the quadratic. It's equal to 4. We have our function x plus 3, so 1 plus 3 is 4. So this is a point of intersection. I'll call them POI from now on with these two graphs. And we're asked to use our graph to give the range of values for which f of x is greater than g of x. So f of x is the first one. When is it greater than the second one? Well, it's definitely greater than it all the way up here. So it looks like at x is less than 1, or less than or equal to 1. So how we would write that? We would write at this point x less than or equal to 1, greater than or equal to 0 for our range of values. Obviously it's greater than in here too, but we've restricted the range. So just along this yellow line we have f of x greater than g of x.